Hey, Arun over here. What's going on? In this video, we're going to talk about closures in Python. I'm going to assume you're familiar with scopes in Python, in general, the LEGB rule. In case you are not, you can check out my video on scopes in Python, linked in the description section below. Okay, with that, let's get started. Let's start by typing a function. And now let's have another function inside the outer function called inner function. Okay, so here's what we have, a function called outer function, which is called by passing the name argument, and inside the outer function we have a nested function called the inner function, which is called without passing any arguments. And this inner function accesses the name variable, but since the inner function doesn't have a variable called name, it will look at its enclosing scope for a variable called name, and there it will find it as the enclosing scope, that is the scope of the function called outer function, has a variable called name. So the inner function is accessing the variable name from its enclosed scope. Now this nested function has its scope available only from inside the scope of the outer function. That is, the inner function can only be called from within the scope of the outer function. Thus, if you call it from the global scope, you cannot access it, and this is quite intuitive. Okay, so we can see when this is executed, the outer function is called by passing the string giant for the name argument, and inside the outer function, the print statement prints the line hello sweet little giant, and then the inner function is defined, and then there is a call to the inner function which looks for the variable called name and finds it in the enclosed scope, and then it uses its value to print the line giant, you're very little. Okay, now let's not call the inner function from inside the outer function, but instead let's just return the inner function from the outer function. Note, I'm not using parentheses here as I'm returning the function. If I use parentheses, then the function would be called and its return value would be returned and not the function itself. Okay, so now the outer function is called and the print statement inside the outer function executes, and then the inner function inside it is not called but returned instead, and it is bound to the variable called our function in the global scope. So let's now call our function. Do you see where I'm going with this? The inner function is bound to our function, and now our function is executed in the global scope. But inner function used a variable called name which it accessed from its enclosed scope. But here it cannot access the enclosed scope as there is none. And also in the global scope we do not have a variable called name. So let's execute this and see what happens. Alright, we can see the print statement on calling the our function is printed, and it's using the value of the name parameter which was passed here, that is giant. Although the enclosing scope is no longer available to the function, it is somehow using the value of the name parameter which was present in the inner function's enclosing scope. So the value of the name variable from the enclosing scope of the inner function was remembered by the function when it was returned from its enclosing scope to be bound to the global variable our function, where it has no access to a variable called name. So a function object that remembers values from its enclosing scope even if they are not present in memory is called closures in Python. So to have closures in Python, we need to have a nested function, that is a function inside a function, and this nested function, that is the inner function, must refer to variables that are present in the enclosing scope of this nested function. And this nested function must be returned from its enclosing scope. Now, when to use closures? With closures, you can avoid using global values as closures provide some form of data hiding. If you're about to implement a class that has just one public method, then closures can come quite handy. And also, decorators in Python extensively use closures. Okay, so before wrapping the video up, recall I said that closures provide some form of data hiding, but nothing in Python is really hidden. So to access those hidden values, here's what we should do. Every function object in Python has a __closure__ attribute which returns a tuple of cell objects if it's a closure. And these cell objects store the value of the data objects that are required by the closure. So to better understand this, I'm going to define a new closure that refers to more than one data object from its enclosing scope. So here you can see that the underscore underscore closure underscore underscore attribute prints a tuple with all the cell objects that stores the values of the data objects that is required by the closure. And to access these values, all you need to do is access a cell object from the tuple of all the cell objects and show its contents using its cell underscore contents attribute. And you can see all the values are now printed. Alrighty, you now know about closures in Python. Okay, so thanks for watching the video. If the video was useful, hit that like button and also share the video with your friends and peers. And hit that red button that says subscribe on it if you haven't already done so. Okay, bye-bye, have fun with Python and see you all next time.